Can you just relax with your stolen pencil? Joffrey. So, could this be a trick question? Maybe it's balanced and it won't accelerate, but you still got to prove it. Maybe it will accelerate this system. So we understand what this is. 3 blocks of whatever you like. Yep, tied on string with 2 pulleys. Assuming it does accelerate, which way do you think it's going to go? Left, Merrill Lakes. Anyone think it's going to go right? Yeah, well, this is a smaller mass, but it's also at a greater angle. Who likes left? 2 of you? Who likes right? 1, 2, 3, 4, 5, 6. And how many abstain? You can't vote twice. 1, 2, that's it? Okay. The good news is it doesn't matter. Okay? So, which way will she go? Yeah, it's a female system. It's like, think of it as a ship. They're always female, right? La boat. It's French. Okay? So, whatever way, I'll just be quiet. Take that way as positive direction, right? Because why, if you think it's going to go one way, then that's the way you're kind of thinking it's positive. Because the other way, the opposite way, seems like it makes more sense to make that a negative way, right? Like the wrong way. There's no right or wrong here. So let's go on and go, because my notes say left, which is opposite to where most of us think it's going to go. I'll take left as a positive direction, okay? But it's not a big deal. If my answer comes out positive, then I was right and it's going left. If my answer comes out as negative, then I was wrong and it's going the other way, okay? It's just, remember, plus and minus is just a convention for direction, right? Our Cartesian coordinate, we could have done this, right? It could have been like that. Why not? Why did we choose to go that way positive and that way negative? Who knows? Mr. Cartesian liked it that way, and it stuck. Okay? He was French, by the way. Okay, so the weight of the 10, that's kilograms, so we're going to assume that, mass minus the weight of the 7 kilogram mass assuming it's going left, I'm assuming the 10 kilogram mass is going to have more weight than the 7 kilogram mass, right? In other words, more force causing it to go left. That's what I'm assuming. That is my net force, right? Because what else is going to cause this thing to move? Is the 8 kilogram mass going to cause this thing to move at all? No. But it will affect how fast or how slow it goes. So I have to take its mass into account. Okay? And you'll see where I do that later. So that is the unbalanced force. That's the net force. Okay, so this guy, it's got weight, mg, just like always. I have this component, mg cosine 20. I've got this component, mg sine 20. Okay, and that is what's going to cause it to go left. What's going to oppose that left motion is going to be this guy here, mg sine 40. Okay? And again, I could be wrong. Maybe I got this backwards. I'll just get a negative number, which means it goes the other way. Okay, does that make sense? This is what's going to cause it to go left. This thing wants to make it to go right. The difference of those is the only thing that's going to cause motion here, right? It's not going up or down. So that's my master equation. Okay, I also want to write here the 8 kilogram mass causes no motion, but it will, irregardless of what direction it goes. The more inertia, the less the force is going to act on it, per se. It's going to reduce acceleration. Okay, so it must be taken into account at some point. Okay, I wish I could keep this all on the same page, but I'm writing too big. So, what is the weight of the 10 kilogram mass? 10 g sine 20 minus, what is the weight of the 7 kilogram mass? 7 g sine 40 equals, what's our formula for the net force? MA. I'll put that here. So the mass, here's where I'm taking it into account. It's the mass of the whole system. 10 plus 8 plus 7 times acceleration. Okay? MA, there's MA. Okay? Kind of makes sense? This is directly proportional to the acceleration. The larger this is, the slower it's going to accelerate. Okay? That's why Formula 1 cars are nice and light. Dragsters, nice and light. So they accelerate really, really, really fast. Top speeds may be the same, but acceleration will be greater. So I want the acceleration. That's the question. Find the acceleration of the system. There's only one unknown in here. 10 g sine 20 bracket minus 7 g sine 40 38.35 wrong pen is 10 and 7 and 8 is 25a, so divide by 25, and what's my acceleration of the system? 1.53.
Isn't it sine 20? Yeah. 10
Oh, did I make a mistake again? What did I do?
30. So you have 9.8 sine 40, you need 9.8 sine 20.
No, 7 sine 40. Yeah, where that should be okay. I'm looking at. That might be the reason. I'm in radians, which doesn't help us. No, that's all correct. what? Yeah, that's not the same answer I got. God, that's what, 2 days in a row I did that? Rookie. Okay, negative. Uh-oh. Let's get rid of this. So that is negative 10.58 is 25a. So divide by 25 and my acceleration is negative 0.423. Is that okay? Let's just go 2. So what does that mean? Yeah, I guessed wrong. Okay, I guessed left. That thing's going to the right. So in some of your questions, it'll say, what is the acceleration of the 7 kilogram block? And maybe a couple of the answers are the same magnitude, but one says left and one says right. You would obviously pick the right one, right? Because I know this thing is now moving right. So, good job, guys. Bonus mark in the next test. I'm kidding.